button? This button, this button, this button, this, okay. Okay, so any questions or anything, or? Oh, yeah. What's that? Which one? Okay. Let me see about. Okay. Okay. Let me take me a minute to get into here. Okay, got to jump through all the hoops to get there. And then I guess the question is whether or not it's better for you with the lights on or the lights off. I guess to me it doesn't matter. Okay. Did I go to the right place? That looks overly big. Okay. They list them different if you zoom in on them. That's really strange. Okay, so it's 16. Okay. Is it better with the lights on or off? What do you think? Oh, okay. Because actually, I found on the stream the camera adjusts automatically. Okay. Now I say that. Okay. Okay. So this thing. Okay. So there were. It was at the. Okay. So the description. Let's do the 500. Okay. There's an A. And so it was the angle, right? Okay. So. So first of all, you know what? I'll use the picture itself. So if we've got this thing, so we want to know, this is kind of strange. Okay, so you know if you pulled on it this way that this member will be in tension. So it's kind of a strange thing. What he shows early in the work is he wants the equivalent load here. So it's basically this. He may be drawing it like this. You may have seen that. And then this, but in fact, the load that's in the member is the reverse. And it kind of bugs me, but it doesn't change anything really. In other words, this member has to pull back this way. And then, there might be a load that this one puts this way. But it really doesn't matter. What you end up doing for this problem is you flip them both, and then you make them both add up to 500. So I don't, So I can't pick that one up and move it, so I'll just sort of leave it like that. There's two ways you could do it. I guess in that matter, you could do it. You could do it both ways if you wanted to. I tend to want to do components because then I can work things out a little bit easier. So if I do one, okay, so the 500 result run. I guess everybody said 500 and everybody said 60 and 45, right? Did everybody say the same thing, or was this one of those varying ones? I don't. Oh, it was? Okay. So I'll just name this one. I'll name that one. And then I'll turn around. Okay, so he says resolve the two components along A, B, and AC. And then I'll put them together in like the triangle. Then I'll show you something bizarre that actually kind of fits in line with what we've done before. But it's, well, I like it, but it's, some people think it's bizarre. But let's just go ahead and do this. I guess, for lack of a better thing, I'll just call it FB. Because if I called it FA, then this one would be FA. So I'll call this one FC. And I'll just sort of stick them really close right here. So if I have that vector and I know it collapses down to here, I'll have whatever its value is, because that's what he wants. He wants to know the resolve the components in AB and AC. I guess I could put AB and AC as a subscript, but I'm too much work. So then you got cosine of 60I, and then you got the other component. Okay, did y'all do it that way? Did y'all do it with components, or did you do the triangles? Which one did y'all do? You did the triangles? I'm gonna be lazy if y'all don't mind. And then I'm gonna show you something really weird. Okay, so then since I called it C, the other one I'm gonna do that way. I'm gonna go ahead and stick with the direction I've drawn and just go ahead with it. And it heads down here. And since I'm calling it C, I have to call it C. Now, let's say I had the vector. I'm going to do something weird. Now I'm going to go ahead and do this. I'm going to redraw it down here because I don't want to mess up what I've got. So I know it's 45 degrees. So I know whatever that is, this one's going to be over square root of 2, and so is this one, because it's 45 degrees. So I could have drawn that smaller, but I guess I can do it like that. But I'm okay here, but I'm not okay on the next one. So in other words, I got to make it now. I know I'm supposed to have these two come along and be, okay, so if the component of the force along AC is required to be, that's kind of weird, but I think that'll be a subscript down in the writing. Well, no, it just says that AC, okay, never mind. As directed along, determine of the 500-pound force. Yeah. Hang on just a second. All right. Yeah.
I have a question.
Yeah.
So why wouldn't you do force of B and force of C the same way, as in like using cosine and sine?
Well, I'm just being lazy.
Okay. You could though, right?
Yeah, you could. The only reason I'm being lazy is because I know if I use 45, the cosine and the sine of 45 is the same thing, and it's 1 over square root of 2. If you look at it, this is equal to that. And every time I see a square, a 45 degree, I immediately go to that square root of 2 thing. And so I'm just trying to shortcut myself. So I just don't want to, I mean, I could write it cosine and sine of 45, but I just, Okay, so I'm supposed to add both of these together, and I'm supposed to get 500 pounds. So, again, how should I say this? I don't want to be, okay, let me say this. I think I'm taking the easy route. You may find that as I do it, it's not the easy route because of the mathematics, but I'm going to keep going that way because I've already started. Now what we'll do is we'll go back and do the triangles in a minute, and then we'll go in and do something really weird. I say weird, I mean, thinking. Think, do, do, do. Okay. Hang on. Hang on. I'm making sure. Okay. Sorry about that. Okay. Oh, and there's construction at your house. Okay, so what I'm going to do, I'm going to add these two and add these two. And then I'm going to take the square root of the squared. You're going to find that it's going to be harder for me to do this problem this way than it would be to do the triangles. But there's probably a way I can get around it. And so, I've already started this. So FB plus FC is equal to this. Oh, good. Okay. FB cosine 60 plus FC over square root of 2. And then I'll do this, FB sine of 60. I kind of regret doing this now. Okay, now I've got to square this and then square that and add it together, and it becomes the square root. And then I'm going to find FB and FC. So do you think this is harder? I think it's harder. So do y'all, who did it component-wise? Would y'all give me permission to go do it vector-wise now? Is that okay? Because I don't want to do it this way now. Let me get us out of the way a little bit. Okay, where's my mouse? There it is. I mean, if you want me to do it this way, that's fine. But now that I've gone down this path, I don't really want to do it this way. So I'm going to add this one and put together to get that one. So let me kind of, let's see. I could move the thing over, or I could just do like this. Let me do this. I go up here, I'm going to draw a line, right? And then I'm going to try my best to use my straight edge, which probably someone threw away. They threw away my straight edge. It was just that piece of paper. Let's see. Well, okay, I'll try my best to do, a Kleenex box, okay. So here's my straight edge. I move it up here, and I just draw a line like that. That line is supposed to be parallel with that line. Does it look that way? Okay. I ruined their Kleenex box, but okay. So I got that. Now, unfortunately, it's kind of tiny. But I guess what we'll try to do our best is kind of looking at it and see what we can figure out here. It looks like they're 90 degrees there, but I don't believe it. Okay, so what I'm going to do, I'll start drawing some lines here. So that one goes out here. If I draw one back here, I'm going to erase it, but I'm going to draw it back here for a minute. And I'm going to say that's 45, but that's not what I want. It's also 45 from here, so it's 90. and this is 45. And now I'm going to erase that line. Now what I got is 60. So I could put a line here, which I already have, and this could be 60. Okay. Now it's going to get kind of junky and it's kind of small. So if you don't mind, I'm going to go ahead and draw one over here. If that's 60, what's that? Isn't that 120? Is that right? And so what I'm going to do is get that off here. So now, I know this is 500. So I got two choices. Well, no, I actually don't have two choices. I have to use, since I have only one distance, I have to use law of cosines. So because the law of sines has a distance and a distance, and I don't have that, I don't think. So now I've got to find, if I'm looking at this, oh gosh, I got to find that angle, or is it this angle? Which one do I have? That angle. I do have this angle? No. Oh, okay. That one, I think. Oh, this one. Okay, so that's this line here. So that's, what is that angle? 75. Okay, so you 75. Now wait a minute. Okay, but okay, so something. Okay, so I said wait a minute because something else entered my mind. What other angle do I have? Makes my brain hurt. Okay, so I'm going to make this bigger because it's getting too small for me. So that looks like it's about like that. And that's kind of fake. So you know what I'm doing? Just so that it doesn't look like 90, I'm going to do that. And then I'm going to try to do this. And then, okay, so I didn't want that to look like 90 because it looks like 90 there. So we got 75 here. We got 500 here. I got 120 there. Okay. What else do I got? I got 45. I got 45 here. And then I got 90 there. So all I got to use is this and this. Did I use, here, let me put that right here. Did I use, hang on. Is that right? 45. That line, yeah, that came off the 45. So 45 is everywhere associated with that line. This one, so where do I go? Did y'all get the other angle? Okay. 500 equals to the sine of something over something else. Now, what's the other, which one am I going for? Because this is, okay, so the problem is, I don't know that I can go off of this one. But I have to go off of this one. But what is it? Yeah. So that part's 60. So the problem is, do I really know where this is? So did anybody do it? Anybody get it? Or was this one of the ones that nobody got?
So AC
AC.
what AC's magnitude is in part A.
Oh, oh,
Yeah,
oh.
so that changes things a little bit. So then you solve for theta.
Well, wait a minute. Where does it say that? Okay, let me zoom out because I may not be seeing everything. Okay. Okay, let me look at this one. Okay, so the 500 points resolved into this 500 pounds. The 500 points to be resolved into components. Oh, if the component along AC is 270. Wait, did you get 270? What did you get? 270 was the component? Yeah, so I see the part A now. Oh, does it? So mine says 270. Can I do 270? What does everybody else's say? Okay. So AC be this one or this one. Okay, so that's what I was, I can't do anything. Okay, so if that's the case, okay, let me do this one too. This is kind of cheating now. So it's 270 and 270. That makes this one a little bit easier. Okay, so this is actually more doable. I didn't read the lower part of that problem. Now I could solve for FB using this. This should be weird because the reason this should be weird is out of this, taking this, you should get the law of sines in some sort of weird way. Okay, so we're looking at 270, and that would be, I don't know, how about alpha? Sine is spelled with I, not an A. Okay, so 270, 500. So move that over. Sine is 75. And I do have MATLAB up. Okay, arc, sine, degrees of 270 divided by 500 times sine in degrees of 75 with 2 parameters. 31? 31.43. Okay, so that's what they got there. And if that's 60, then 31 minus 60 is around 29. Okay, so he shows 28.6. So here, 60 minus 31.43. If I go up arrow, and then I say 60 minus 28.56. So that's what he ends up getting. Okay, well, I'm glad he gave us that 270. Otherwise, we wouldn't have known what to do. So I'm standing here staring at it thinking, okay, is my brain just off or is there something missing here? And obviously there was. Did that kind of answer the question, so to speak? Well, yeah. Because what happened was, okay, so I got to add something. Wait a minute. Okay, I got to add theta plus the alpha I got. It's got to be equal to 60. So what I'm looking for is the theta. So take my answer here, move it on the other side, and I take 60 minus that. That gives me my theta. Does that make sense? So now I could have done it what I thought initially was the easier way by breaking it into components, but that is not what. Here's another bizarre way to do it. He starts laughing immediately. Okay. I almost am hesitant to do it, but I kind of feel like I want to try it and see if it works. If it doesn't work, from this point forward, forget everything I said. So if I've got a vector that's, say, 500, and it's like a theta right there, then that vector, I guess it has a name for it, f. And his vector f is equal to 500 cosine theta this way plus 500 sine of theta that way. Does that make sense? So does that part make sense? Now, since I don't know theta, we got a problem here. Okay, so he gave us, what did he give us? He gave us that this one was 270. This one, right? This one was 270. So now I'm going to do something really weird in a good or bad way. Okay, so I'm going to draw this FC. It's equal to 270, whoops. And, okay, here I got my 45. Okay, so it's 270 over square root of 2 that way, 270 over square root of 2 this way. So essentially I'm rewriting this, right? Okay, are we okay so far? Did everything make sense so far? Did those two, let me let you think about that for a minute. I'll get this out of the way because I might use this space. Okay, so we okay? So I'm going to do something really strange. I'm going to dot these two. But what I'm going to do is I'm going to basically dot this vector with a unit vector pointing that way. What do you think the unit vector pointing that way would be? If it's pointing that way, what would it be? So this is a unit vector, so there's a unit vector. Okay, wouldn't it be 1 over square root of 2i minus 1 over square root of 2j? Now, I want to take some time to make sure that makes sense to you. So I'm basically finding a unit vector that just points this way. That vector, if you take the square, take that squared, then you take that squared, you add them together, you get a 1/2, and a 1/2 gives you 1, and you got a unit vector that way. What would happen, I don't know the answer to this, but what would happen if I dotted this with the unit vector pointing along from A to C? Well, the unit vector is this. But what would its value be? Wouldn't it be the 270? Yeah, because that's what he told me. He said the component along the AC is supposed to be 270.
I didn't get that. Could you try again?
No, I can't. No, so that, okay. I don't know why she does this. So, okay, so let me restate what I'm saying, and then I'll ask the question to make sure we cleared it. So we are picking a unit vector along this, Now, what would happen if I dotted this with that? What should its magnitude be? Yeah, and look at his words. The component along AC is required to be 270. So I'm going to contend for a moment that since he told me that, this should be 270. Okay, so it may make you feel uneasy for the moment, but let me just try to work this out and see if it works out okay. So if I do this, I'd multiply that times that. Now, I'm kind of leaping out there, so I hope I'm not leaping in a bad sense. But, and then I'm going to take this times that. Now, unfortunately, I think I was supposed to have a minus sign there. And so I don't know what happened, but anyway. And now I'm supposed to be 500 over square root of 2 of sine of theta. And this is supposed to be that. Okay, so what would the angle be? Now I'm going to cheat and take the answer and figure it out, and let's plug it in and see if it turns out to be that. Are you okay with that? Instead of me rigorously solving for theta, what would that be? Okay, it's a different theta here. Okay, so this is your theta. Well, now I take that back. It's the same theta. So I'm going to sort of, if you're okay with me, like inserting 28.6 degrees and 28.6, and actually it had some other digits on it. But I'm going to figure this out. I want to see what happens if I plug this in. I'm going to see if it does end up being 270. Now I hope it is, or else I'll just barf right here in the trash can. And I'll do it in the hallway if I do that so that you won't have to watch. But cosine, now each one of them is the same magnitude. So what I'm going to do in MATLAB, I'm going to take the 500, divide by square root of 2, times cosine of 28 minus sine of 28, if you're okay with that. Times, did I do that right? Cosine degree, 28.6 or 8? Or 28 point, yeah, it's 28.6. So I think I got that right. Did I just hit the key wrong? No. Oh, wait. There's got to be a degree. Uh-oh. Does not or turn out to be the right. So if you don't mind, I'll step out there and barf if you want me to. Why does it not turn out to be that? Supposed to be what? Yeah, I think there's another component. So if we were looking, okay, let's make sure I did my math right. So what I'll do, how can I do this? You know what I'll do is I'll put this in MATLAB the way it's supposed to be. So in other words, he says, give me a minute and let's see if I can see if my mistakes aren't ruining me. F is supposed to be 500. Well, first let's just say T is equal to 28.6. That's my angle. So then I can just use that. And I'll say F is equal to, and I'll say 500 times cosine in degrees of theta. Did I do that right? Cosine, that's the going that way, and then sine goes this way. Plus, no, actually, I want to put it in the matrix form. Degree of theta, and that's the matrix. So I get 430 going to the right and 239 going up. Now I'm going to put in the UAC. UAC, too many A's, is equal to, they're both 1 over square root of 2, but one is in one direction, one's in the other. Let's make sure I did that right. Uh-oh. I think that maybe I'm supposed to put a multiplier right there. Okay, so I think I got that one right. 0.707 to the right, 0.7071 down. Okay. Now let's dot them through here. Dot F and UAC. Still 141. So so my initial thought here was that I would find, and that's probably the case, but if there's a certain portion of it that needs to be added to here as well. So if this were basically by itself, I would be okay. But I hope that didn't confuse the issue there. Sorry about that. So I did find the component along there, but it's not that. Okay, so if I did a component along B, that wouldn't solve any, I still wouldn't be able to use a dot product there. Yeah. However, I still can use a dot product. Okay, so my mindset may be off a little bit. But let's, if you're okay with me going down another path for a minute, let's see what would happen if I did this. I know I hope I'm not chasing you too far around the barnyard, but let's try this. I do know FAC, right? And it's 270, right? Now, if I dot these two, let's just do it like this. I'll dot it on the computer, and what we'll get is the cosine of the angle between this vector and that vector, and then we could take that off and find that vector between F and FAC. So I can find this, I can find that, so I can do this cosine inverse F and FAC. But you can't do that either, because that would be, no, that's not going to work either. So everything I said before I said that, you can erase that thought process, because that requires you to know the angle in order to find the angle. So that's fine to know the angle to find the angle, but forget all that. So yes, I found the component along a vector this way, but there is another, I need to have an additional component along there. So, okay, I hope I didn't confuse it. If you're watching the video, you can just delete that last part that I was talking about, because it's not going to do you any good. So many times I explore in the so was there another component to this? Oh, he wants to know the other force. Well, okay, so do you know how to find that part? The other law of sines? So y'all get that part? Okay. The theta? Okay, so we got stuck, well, okay. Oh, wait a minute. We got stuck to the point where we actually found that, and it was 32 point something, because I erased it. And then I know that this and this have to go together to give me 60. So I had to take this and move to the other side. So I had to find the angle that he's asking for. I had to find that. And I think mine was like 32. I could bring it back up on MATLAB, but I think it was like 32 something, which you subtract that and it gives you the actual 28.6. Looks like he did it in some sort of bizarre way, but that's okay.
So if we drew, because how it worked this originally was, I drew the triangle on the other side of the force vector. So it was like the force vector was on top. So from there, could we solve for theta or no?
Well, okay. You mean directly?
No. Well, I mean, even if we do it directly, we're gonna find the total theta. We're not gonna find right.
Yeah. So in other words, okay, let me see if I can do a good job of mimicking this. So what you're saying is instead of drawing this leg first, you drew that one. Okay. Now I'm going to try my best to draw it in such a way that it doesn't show up to be 90. And so this is the other one. So this is his theta. And so now, okay, if you drew this down here, it's kicked out at 45. This doesn't look like 45. Sorry, it doesn't look like 45. Let me make it look like 45 a little more. How about that? So what we'll end up with this one, we'll end up finding something like that and call that gamma, because I already used alpha. So let's say that. So in this one, it's 45 plus theta equals gamma, right? Did I do that right?
So how did you get the 45? That's
Oh, that's because this line that you drew, it was on the 45.
okay. That's what this stuff on.
Yeah.
That's it.
Okay. So what did y'all put? Did y'all put a 60 or something in there, or did you?
No, I got the right answer. I was just trying to remember how I got it originally.
Oh, okay. Yeah, and actually, I don't even want to think about what he did because I don't, you know. I mean, it's good to try different ways. I guess we could have gone in and taken this and squared that, but I think what was happening to me initially is I was like, this is going to be more math than actually drawing the vectors. And so did that all work out? So I think what I'm going to do, since this is the first week, I'm going to sort of boot the due date and the penalty back. There's some things the system allows me to do, and that's move a due date. So did everybody complete it? Do y'all want another try at it, or? Okay, so I'll kick it out to like Thursday or something and let you kind of go back at it. So I don't want to get in that habit. Here's why, because what happens is, I mean, we're all human, and you'll say, oh, he'll kick it back Thursday, and then you'll do it, and then so it come in on Friday. Oh, well, wait a minute. I got a test on Friday. I got this, and then you cram yourself up. So we'll just, since it's the first one, we'll boot it back, and then we'll get back in sync, you know. And so I think I gave us enough time to all get the site and get everything going. Actually, from the discussion in dynamics a couple hours ago and from this, I kind of think this is a good thing because it gets us all going, and then it gives you targeted questions. Then you come in and we ask them. I think instead of booting it back, I'll figure out I'll look at the system and figure out how to manage things, because I think it was a 10% deduction every day it was late. And I think there's a balance between knowing how to work it and getting a good score. So in other words, okay, think about it like this. If you had to, your theory should be, you should learn it, regardless of your score. So what you got to do is, from the other perspective, is to make sure that if someone who actually learned it, even though they had to do it, you know, and made a 90 because they got it done a day late, versus someone who got a 90 who didn't know it but got it done early, you would prefer the 90 who did it late than the 90 who did. So I'm going to try to figure out how to do this as we go along. I can't really put my finger on how to do it because I'm not sure I know how the system actually completely adds scores into the grade book. I found out that if you ask for assistance, it docks you. And that was like, okay, that's not what I thought would happen. So I'm going to go and see if I can take that part off. If I can, I'll take that off. I do know that if I do an adjustment, it just sweeps over and does the whole thing. So if it's something that happened in the past, it'll sweep over and redo that one. So I need to figure out. So I'm learning the system too, is what I guess I'm saying. Yeah, let's do it on Friday. And what I think I'm going to do is I had 3 problems in there. I think what I'm going to do is delete 2 and just put 1 on it. So this will be our first one. And I'll just pick one of the ones that I may even pick that one, you know. And what I'm doing, that's what I'm doing in Dynamics too, is I'm looking at the one that had the most questions, and then because so first of all, if there are questions, I generally talk about it. If I don't talk about it, then I assume everybody got it. And so it's kind of like, you can go look at the lecture and see what it is, and then I'll put the problem on there. So I think that's the way I'm going to do it.
We don't have to be in class.
Nah, you can go wherever. As long as you have an internet connection. I think what I'm going to do, I told them, it's originally set for Thursday at midnight to Saturday at midnight. And I hate to make it go to Sunday at midnight because your homework's due then, but I think I'm going to go ahead and do that for this one, just so that we have enough time to do that. And then get a feedback on that. I hate to just have you, it's like force feeding you too much at the same time, but
So
yeah.
it's going to be on Pearson or on Blackboard?
Well, on both. So you go to Pearson through Blackboard, and then it's the same. So it has exactly the same format as the homework.
Okay.
So it's exactly the same. You just go in and here's the problem, and you're like, oh crap, I already did this one. And so it's kind of like, so that's the way I'm going to kind of do this.
So we're going to have a lecture Friday then?
I mean, I can show up, but you don't have to show up. So what I was initially thinking is that we'd all sit here and everybody bring their laptops, but now I'm like, why do that? I mean, if you can go, and so if we come, I'm not going to say anything.
Yeah.
So I'll just sit up here and look like a bump on a log or something. I mean, so I think that's what I want to kind of do. If there's a break or something, what I mean by break in our flow, like if third week into it we're having a problem with something and we need to have a Friday session, we'll do it. If not, that's what I was figuring, we'll do this from now on. And the thing is, and there's a balance between all this, because in a way you learn this kind of stuff by doing it. And so then the question is, how do you go and do this? And, there's just, on my end, I hate to say this, but we don't have any teaching assistants or any sort of structure towards that. So I'm like, what can I get to replace that? And this thing seems to be something there, and then I can answer questions with regard to it. And so I'm trying to do the best with what resources I have. Believe it or not, all this, it's like 2 years ago when COVID hit. If you look back, you'll see the lectures I had were much better off than the ones I'm producing now, because this didn't work. And I tried to do the thing in the Wi-Fi. It's like that somehow they turned the Wi-Fi speed way down to nothing. So I don't know, unless have y'all noticed that? Is the Wi-Fi much slower than it used to be, or?
In this building, it goes in
Oh, okay. So that's why I devoted to just doing the camera and just, plus I'm walking around, I'm getting exercise at least, so, So I'll kick that back. So just keep working on it. There will be no effect that you will see. Just keep working on it. The effect will just, all of a sudden your grade in the blackboard will change. So if you even completed it, if you completed it yesterday, nothing will change. If you go back and keep working on it and complete it today, initially you'll get a grade, but then after I adjust the system, the grade will pop up a little bit. So does that make sense? All right.